We are doing airborne wind energy. Airborne wind energy is a new production technology, and it's a production technology that could make a big impact on our ability to achieve net zero by 2050. The world is not on track. We are lacking behind the targets. We see that we have to rely more on solar, less on wind because of supply chain issues and permitting issues in the wind sector. But solar is not really suited to have this role in the mix with its high intermittency, and something we see already today with 19% of the daylight hours having negative energy prices in Germany. We will see much more of that, and it's going to be a very high premium when we need to store the solar energy for longer period of times. Airborne wind can come in and correct this. And we see also that the challenge is immense that we are facing. If we're going to do this energy mix, there need to happen a lot. And at the same time, we see the global politics is changing from focus on sustainability and over to security. No, this is actually a good thing for airborne wind energy. And we realize that this is what already is financing our activity. And I will get back to that shortly. The way we produce energy is to fly a kite crosswind. So it flies like a kite. We utilize the lift that the wing produces to pull attractive force on a tether that comes from a ground-based generator. So all the electricity is produced on the ground. The kite's job is to pull out the tether. So it flies in a helical pattern, producing power 90% of the time, and 10% of the time we are flipping it over, pulling it effortlessly back, and then we go into a new production cycle. And this is how we continue to produce energy. When we need to take off from the ground, we use propellers, so we can take off independent of the ground wind condition, fly up where the winds are stronger and more consistent. And these propellers we only use for a few minutes during takeoff, and then they are folded away, because through the whole production and retraction phase, the kite is operating as a glider aircraft. There is a small propeller on top of the kite. This one is producing electricity to the battery on board, or a control system. It's no conductors in the tether that you saw there. It's just a rope going to the generator at the ground. So here you see the transition to crosswind flight. That's the production flight. Everything you see here is automatic. Push on a button on the ground, and then it completes the full operation. This is a 20 kilowatt prototype that are on top of the looper up in 330 meters above the ground. As comparison, the tallest wind turbines that has been built in the world today has a tip height of 287 meters. So we are definitely tapping into totally new wind resources there. You can see the wings are bending quite a lot. This is a 60 kilo kite, 20 kilowatt prototype. It pulls 8,000 Newton on the tether. It could lift a small car from the ground. The wing load is about 10 times higher than the strongest aircrafts in its same size, the aerobatic aircraft. So we are definitely pushing the limits there, but we do it successfully. And the main benefit with airborne wind, as I see it, is that we line up the forces in a smarter way. So we handle the same energy output as both conventional wind and solar with only 10% of the materials. And this is what's financing Kitemill these days, because this can change the trade balance. You can produce your energy equipment without relying on the supply chain, and especially the increased dominance by China in the supply of anything, delivering now 98% of the solar equipment. And I'm pretty sure if you look into the supply chain, they are above 80%, 50% of the wind turbine equipment already. But the raw material is one security side that is important in the future, but it could also be supply security, because as I mentioned in the video, we are opening up totally new wind resources. So this means nations that didn't have viable wind resources can get viable wind resources by utilizing airborne wind energy. And we focus on four main value propositions. And the first one is the availability. airborne wind energy will produce more energy more often, so you need less storage. There will not be a premium compared to other sources. We are talking about capacity factors above 50%, and as comparison, the average nuclear power plant has a capacity factor on 60%, so not far from the same availability as nuclear. And of course, when you increase yield, which increased production will give, and then you reduce capex, since we have less material, there is less cost in all parts of the supply chain, also less change in the terrain and impact on the nature. But this cost reduction combined with increased production gives a very beneficial levelized cost of energy. In the later years, we have also looked into this relocation. Since we leave less cost on the site, we can actually, for the first time in the history, relocate renewable energy assets during its financial lifespan. And that opens up new opportunities. We can build these on temporary permits, because if the permanent permit has not been accomplished, the developer can relocate the equipment and recover most of the cost. That can accelerate the transition to net zero more than any other technologies on the market. Another advantage with relocation is less risk for stranded assets. And this is risks that are increasing with the climate change, the rapid change in market condition in the transition to net zero, and also with all unfortunate global conflicts and so on. The fourth and last value proposition is energy density, and that's how we use land area. By addressing a much bigger airspace from the same ground area, we can increase the density. This value proposition is the one that is the most depending on system scale, as bigger kites will fly slower and it will be safer to fly them or coordinate them closer together. But we already have a roadmap of achieving significant energy density increase by the second model, the second commercial model. So, and that would open up the pad constraint market, but which is very depending on site utilization. That's a complex market segment. We believe that the first commercial market will be the grid constraint market. This is further away from populated dense area, where space is not the problem, but the grid capacity, how to get the energy back to the grid. And actually, this represents more than 50% of the total global wind energy market in the coming years. And there is many niches within this market segment that we can address without competing with land-based onshore wind. But the reason why the technology will be beneficial there is, of course, the high availability, that we utilize the grid better. The first market segment we will start with is the demonstration market. And in 2024, we already saw that Germany launched feed-in tariffs for airborne wind, which is a signal that these incentives will come and enable airborne wind as the previous energy production technology has come. This time it will be combined with push incentives, more capex support, like we also see when Kitemill has been granted the Innovation Fund project, the NAVAP, where CO2 taxation money is channeled back to enable new energy production technology. In this project, we're going to demonstrate 12 100-kilowatt systems in a 3-year monitoring period. The start operation is early as 2027. So that's the first pre-commercial project, but it will also have customers involved. Kitemill team consists of 25 people, 9 nations, strong competence within the wind industry, several parts of the supply chain, along with general aviation and automotive. So industrial experience is one of our strengths, but we also have a very, very well developed supply chain network and partners globally. So I won't go through the persons today. where we are now is that we can fly significant endurance flights in up to 3 to 4 hours, and we are still focusing on endurance. To get further, we need to automate failure modes and to automate landing so we can turn our back to the system, and this is the focus in 2024 and 2025. We have never focused on optimizing energy production, but we do supply some very good production curves showing that the technology works. And one thing that separates Kitemill from the other airborne wind companies is the retraction phase. We have a much higher cycle performance by being able to pull the kite back faster, only using 10% of the time for that. So in this flight, we produce almost 8 kilowatt hours, 5 to 6 in average. We believe this one can be lifted because there is so many things that can be improved, but already good. Our product roadmap starts with the KM2 system that is on 100 kilowatt. It's been on the drawing tables for a few years, so we are ready to start to build it, and it will take 2 years to get it into operation. 2026 is the year it can start to fly, and 2027 it can go into the NAVAP operation. This model will be the most produced model we will ever design, giving clean, affordable energy to the remaining 1 billion people on Earth that doesn't have it. It's a perfect model into that market segment. Kitemill will mainly use this in the demonstration market to qualify for the next model, because at 0.5 megawatt size, airborne wind energy can present most cost-efficient energy production technology over most part of the global land area. This is the tipping point when airborne wind can compete with conventional wind, being mature and scale up to large enough volumes. And after that, airborne wind can continue to be scaled up and optimized, and it could potentially dominate the global energy mix sometimes in the future. We will continue to fly the 20 kilowatt at least until 2027. So we are investing in this now, improving our production methods and the design for that. So that's always in the bottom of the funding plan, that we have the resources to operate this. We are raising now 16 million euro in the next round after this one. This is a Series A round. When we close that, it will leverage up to 30 million euro with grants. So this is a very big funding round. And of this, we have already lined up 8 million through the EIC fund. And there is also some strong candidates bringing it up to maybe 12 million. No, we say 60% has been secured. So right now we are doing a seed round, and this is to fund our runway. It might take some time to close this round, and it's important that we have enough cash to get through this period. So I think we need to spend the last 4 minutes for questions. So I thank you for attention so far. Yes. Is there anything on your mind?
Yeah, I have a question. Lothar speaking.
Yes.
What about patents? Do you have any patents to protect your system, or does it get copied by Chinese manufacturers? Or,
No, not only patents. We have 5 granted patents, and we have a lot of effort on that. Tobin Baum, that is the most successful inventor, investors through all time, is now responsible for the IPR development in Kitemill. So we have a really long list with invention disclosures and we are in process on filing new even better patents, and it's only cost that regulate how much we can protect. So we are in a really good IP position, both with existing patents and with coming ones.
Another question I have, it's for safety. as you pulling a rope which is going from the kite to the generator. So any safety issues, you know, or in case a rope fails, or you know, how you can make sure, because you can go up really high, and you know, any safety concerns.
That is actually what we have been working on this year. So one of the functions that we have developed is as an overload protection. The kite can disconnect and land safely without the tether connected. We just had a situation where that function worked now. But in general, we follow the rules for unmanned aviation, and we feel that though regulatory work will be an important part and a big cost factor also in the years ahead of us, the regulation is very well adapted to receive airborne wind energy with the rules for unmanned aviation. And we work very well together with the CAA, that is responsible of both the safety in the air between other aircrafts and safety for the people on the ground.
So, and also then you have to consider maintenance cost, because if you're pulling 24/7, you know, what would be the lifetime, and what is the downtime of a system, so that you have to replace the rope, you know,
and that's very well observed, because I talked about yield and income and capex, but no operational cost. But we calculate with similar operational cost as for conventional wind. We will have more frequent inspection and maintenance, but much easier access. And like you also say, with the downtime, we also have the opportunity to replace kites that are not in operation because of maintenance, to obtain a high availability. So everything is designed for 20 years lifespan.
Okay, thank you. Thanks.
Yes. Gerald from the Netherlands. A small question. This coming round is for 400K. This will cover basically, I think, 3 months' salaries for 25 people. So how's your cash flow going to look like?
Yeah, Oscar can answer that one.
Yeah, it's not 25 full-time employees to start with. It's 14 now, or 13. 14 or 13.
Consultants.
We have incoming close to 20 million Norwegian kroners in soft funding this year. Mostly EIC funding late in the year, and then also some domestic grant agreements coming in September, I think. We have a bank bridge for that. So it's quite good if you look at it overall. It's a bit strained if you look at it liquidity-wise, and that's why we are choosing to do this crowdfunding now to fix the liquidity situation, while we also will work on a bigger VC funding round. And we have contingency plans if we would need to scale down for a time to fix liquidity situations. But overall, I think this is close to as good as Kitemill has ever had in terms of finance runway in absolute amounts.
Yeah, and of course we've been taking care of our liquidity for many years, and I think we have proven that we are very good in balancing this, not to take too high risk, but still manage to push the team forward. We have been increasing the team all the time, and to push the technology forward and make sure all the money goes to advancing on the technology.
And just a technical question. I'm a structural engineer. So you have quite a lot of force on the cable. So how does your foundation look like? Because you must have some serious foundation in this design.
That's yeah. So if you're a structural engineer, I can answer in a different way maybe. But we see a pull force on the tether that is maybe 2 or 3 times higher than the actual load on a wind turbine. But we don't have the rotation, the torque that a wind turbine tower see. And all these forces are working away from the ground, so it reduces the forces on the foundation and so on. So this is the key of us only operating 10% of the materials.
I'm not convinced quite yet, but anyway,
okay. But also safety factors, and so we design things for the worst load case. So we put up the load cases in the beginning, and everything is designed after that with a good safety margin. And then we also see that there is a lot to gain on load control. So we believe that the first models that we will build, we already have built of the KM1, and the first KM2 models will be designed of very conservative load cases. And we believe that once they are in operation, we can make the snowball really roll in the right direction. And that's what you have seen in wind energy for decades, that there has been a very good learning curve there.
Yeah, but from perspective of communicating to the public, I think it's important that you do explain a little bit what's going to happen under the ground, because now we just see a box and a cable and a kite, but this box, because it's my discipline, I know that this box there's something going to happen to this box, and also permit-wise, putting a permanent foundation is quite a different trajectory than if we were just to put, for example, just a truck, for example. In your case, it will never be just a truck, because that will be pulled away. So I think communication-wise, it will be, I think, fair to explain a little bit what's also going under the ground. But that's just an advice. That's all.
Okay, yeah, but I would love to discuss this in detail with you at some point, because I still think we have something to learn there, but and maybe we can also explain this better, how we think it will be. Good.
May I ask? My name is Arne Kålansrud from Tritech. First of all, congratulations with a good presentation and coming so far. It's maybe in the information from the crowdfunding company, but what is the valuation and the future fundraisers and so on? Can you say a bit more about that?
Okay.
Yeah. So this is a convertible loan note, same terms as our lead investors has entered into. The pricing is tied to future funding events above 1 million euros. The investors here will get 20% discount if it happens within 12 months and 30% discount if it happens within 2 years, sorry. It's also capped at 25 million euros, which is approximately the pricing we had after our last major fundraise, where we collected 1.5 million euros mainly from the Netherlands.
Okay.
If no funding event should occur, then there's the downside protection with no fixed price. So then there will be a creditor meeting to decide the fair value and together with the new investors. So we feel it's balanced and fair and based on what we've previously achieved. It's also approximately close to money spent in Kitemill over the years, not including KPS and e-kite spending. So investors get that for free.
Okay. And how much are the shares from the founders or the working?
Founders and team, excluding Jon and Jan, who are founder investors, is approximately 20%, including the warrants. subscription warrants, part of our employee share option program. If you include Japian and Jon, then it's somewhere around 2/3 controlled by founders and team.
Okay.
Yeah.
Thank you.
Yeah, but those two are both investors and founders or co-founders, so kind of treated separately.
Yeah, I see. Thank you. Good.
Yeah. So if there is no more questions, then,
sorry, I have one more. If no one else, how close to like airports and so on can you operate? Is it possible to say anything about that, or?
That's a good question. So we are operating at an airport now, but that's not a commercially open airport, but it is a used airport. So in that sense, we can operate on the airport. But of course, when it comes to commercial airports, one of the first thing we are looking into when we plan with sites is that we are not in conflict with the in-flight paths and so on. We could be inside the controlled airspace of the airports. And we are also working very closely now with use-based service provider, because Europe have decided to implement use-based, which is a way to organize unmanned aviation. So we will put up a sandbox at least. And if we accomplish this, and if we do this right, it will be much, much easier to get permits for operating airborne wind system than it will be to get permits to operate wind turbines, which is consider aviation obstacles. There will be problem for aviation for its entire lifespan. We can be a part of the airspace organization. And that is also something our customers have said they want to see.
And in the foundation box on ground, are you using converter or batteries now for the testing? And what is the solution for grid scale?
Yeah, we use converters, but no batteries.
Okay.
We do have one ground station with batteries also, so we can do that, but that's not necessary in utility scale implementation. The grid will perfectly fine, except supply directly from our inverters.
Yeah. Okay. How much is the cost for? Maybe too detailed, but in percentage ballpark, how much is the cost for the inverter versus the rest of the technology?
That's the markup of power electronics is very high. So even talking to the people in that industry, they recommend us to look into options there. But obviously it's not higher than it will be for solar or other applications and so on. So we do have good control of the cost there, but I would rather say it's an opportunity if you can make if you look on the cost of the power electronic for the electric cars, then you see that there is a big opportunity to cut cost and on that part when you get the volume up, and that's one of the good thing with airborne wind energy. We will see a deployment of much more higher number of smaller units that can benefit these kind of cost elements.
Yeah. Good.
Perfect. Then I'll thank you all for attending, and also for those of you who just watched the video. I'm sorry that we was not ready 1 hour ago when you were ready, but perfect. Thank you for your time and have a good day.